Good morning, students. The last class means we discussed the last chapter, that is states of matter. Now we are going to start with a new chapter, that is I have not started in J1 or also J2. I done in the last starting in online only. Now again due to COVID reasons, again I am starting in online only. That is classification of classification of elements and periodicity in properties means in a periodical table we're going to discuss that classifications and classification of elements. Means we know that elements are classified into three, that is SPDF, correct? No, that's all based on the rules we are going to study. First of all, in this chapter we are going to study about Mendeleev. We're going to study about Mendeleev periodical law, and we are going to study about its merits and demerits of this law, and after that we are going to study about modern periodic table. In this what Mendeleev not explained, he will try to explain and he will be done. After that we are going to study about in periodical table. Means we already I explained in the class that in the periodical table like this. The periodical table is, that is S block, P block and D block and F block elements are arranged, correct? No, my dear students, I written in the class. Please understand that classification of elements in periodical. In this video we are going to study about classification, that is Mendeleev periodical law and modern periodical law. In that after that we are going to talk about each groups like S block elements and P block elements and D block elements, F block elements. Means in the S block there is two subgroups, that is alkaline metals, alkaline earth metals. When come to P block, it's have classified into, there is 5, that is we know that from group 13 to group 17. And D block or transition elements. We are going to study deeply in the video. Okay, what we are going to study after this nomenclatures of in this video we are going to study last topic, that is nomenclature of elements, with atomic number greater than 100 means greater the atomic number. There's 92 natural elements, 24 artificial elements we're going to study in this video. Okay.
Mendeleev periodic law. Mendeleev periodical law means the Mendeleev classifications. First of all, Mendeleev is a Russian. He was done in he was introduced in the periodical table in 1869. Okay, the Mendeleev he give another contribution, that is invented that barometer. The barometer is nothing but it used to measure the atmosphere pressure. Atmosphere pressure. Okay, in 1869, the first person who done that in 1869. He done the 63 elements, or Mendeleev, the 63 elements, he arranged the periodical means 63 elements he arranged in while taking the atomic masses increasing. It arranged based on the atomic masses. Atomic masses in periodical table. He arranged the 63 elements in periodical table by increasing the atomic mass. Periodical table. And also we call that Mendeleev is the father of periodical table. Father of periodical table. What he done? He taken 8 verticals. You see, this is what he taken that Mendeleev, the group. It is all the groups. It's all periods. Okay. What he done? He taken that 8 vertical columns. We call that groups. 8 vertical. You see, 1, 2, 3, 4, 5, 6, 7, 8. 8 vertical called that groups. Okay. Then we taken that 6 horizontal rows. We call that periods, or you also call that series. We call that series. Okay, you see, in group 1, we am taking that group 1. I am written A and B, means the group is divided into A and B. You can see in another NCERT textbooks they written the 2 columns. Okay, I written in only one tabular column to convey you. Okay, what groups are divided into subgroups, like groups are divided into like 1A or 1B, 1A or 1B, or like not only in first group, you can see in second, third, fourth, fifth, sixth, seventh, up to 7th it has the subgroups. The groups up to 1 to 7 it have subgroups like 1A, 1B, 2A, 2B, 3A, 3B. Okay, like that. But no 8 subgroups. No 8 subgroups. Okay, you want to remember this point. Next we are going to talk about that. Is taken that if we defined Mendel's periodical table, if we define Mendel's periodical table, if we define the physical and chemical properties of element are the periodic function of their atomic masses or atomic weight. We can write that atomic masses. The definition is telling that physical and chemical properties of element means this element 63 elements are in the periodical function of their atomic masses. If we talk that what is this atomic mass, you see atomic mass is nothing but mass of the one element. You see, we'll write that what is atomic mass is nothing but mass of one element. If we talk about what is the physical property, is telling the physical and chemical property. Physical is nothing but if we talk element density or melting point or boiling point. Okay, if we talk a chemical property, the reaction, see what the chemical property, if you talk, the chemical property is nothing but reaction of one element to another element. Reaction of one element to another element. You see, the physical and chemical properties of elements are there in periodical functions on their atomic mass. Atomic mass is nothing mass of the one element. Physical properties nothing but density, mass, boiling point of each element. And chemical, if one element reacts with another element, what happens? The reactions. Okay, like that. For example, if it reacts with oxygen or hydrogen, okay, it gives highly reactive found in readily and large components. Okay, if reacts the elements, what they are written here, the elements reacts with oxygen or hydrogen, will get. Why it reacts with oxygen and hydrogen? Because highly reactivity. These elements are highly reactive. Another one is found in readily. It can found readily. Another one is if elements reacts with oxygen or hydrogen, will get large components. Large compounds. How can we tell? For example, we take lithium reacts with oxygen or hydrogen. What will happen? For example, lithium reacts with oxygen, it gives lithium oxide. We can write it as R2O, correct? No, for that only in periodical table I written that R2O. All these group elements, if reacts with oxygen, it gives the general R2O. Like that form only I written here R2O. Okay, you can write another one, that is lithium reacts with hydrogen, it gives lithium hydride. You can write RH. For that only I written that R2O and RH. R2O is nothing but reacts with oxygen. RH is nothing but reacts with hydrogens. I have written that generally. You can see it in each and every group, and we can take another example also, that is a sodium reacts. I will take another group, another period, that is sodium reacts with oxygen. We can check it. Na2O, correct no? Similarly it comes NO2. Similarly R2O, or Na, sodium reacts with hydrogens, it forms sodium hydrate. Similarly RH. For that purpose only I told that. Okay, you see, next we are going to talk about a very important topic, that is Eka. What is this Eka? Eka is a Greek word next to. The Eka is nothing but next to. Eka is nothing but next to. Okay, you see, I left some spaces here, that is in fourth I left here, correct no? This element, what happened, these elements. Okay, for that I will write, okay, what is this Eka? Okay, what happens? Okay, you see, Eka is nothing but next to. For example, you take a boron, okay, Eka boron, or Eka silicon, okay, Eka aluminium. For example, if you take Eka aluminium, you will get, you see, Eka aluminium. After Mendeleev, there was introduced the gallium, but Eka aluminium is not told aluminium, it told Eka. It told that, yeah, what it told that in this periodical table, it told Eka aluminium, it told that. Okay, Eka aluminium, it told that, but it not invented. Okay, Eka aluminium, and he also not invented that Eka is also not invented. Okay, Eka aluminium is told that Eka, that's all. If Eka atomic mass, I will write shortcutly, atomic mass is not told Eka aluminium, it told Eka. Okay, Eka aluminium is next to. I already told that Eka is nothing but next to. Eka aluminium is next to how much atomic mass? He told that atomic mass approximately 68. Okay, after invention of gallium, we got the 69.7. It is approximately, and also he given that oxide formula. You see, he given that oxide formula, that is R2O3. Correct? No, R2O3. He given that oxide formula. That is Al2O3. If gallium reacts with oxygen, it will also get GaO3. It's that we got R2O3. We got this gallium. Okay. Next we are going to study about Mendeleev periodical table. Okay. While seeing this table only, we will write it. Okay, while seeing this periodical table only, we will write it, what happening in this. Okay, see Mendeleev periodical table. Already I defined that the property, correct no? Mendeleev periodic table. Okay, Mendeleev periodical table. Its merit. What he given that? Grouping of element. First he was given that grouping of elements. Correct no? He make a groups. Okay. Grouping of elements. Another one predicted that undiscovered. You see, he predicted that one thing, correct? No, he predicted that one thing, eka aluminum or eka boron, okay, eka silicon, eka magnesium, okay. What he given that predicted prediction of undiscovered elements, like eka aluminum we got gallium, correct? No, eka silicon we got germanium, eka boron you got scandium, eka magnesium you got technetium. He is predicted undiscovered element, that is 4. Okay, he called that eka aluminum, eka silicon, eka boron, eka magnesium. He told that after his death they have invented that 4, but the 4 also is equal to atomic masses, and also oxide formulas are same. Okay, for that he was predicted the undiscovered element. Another he also prediction of the properties of undiscovered, he also predicted, correct? No, he given that prediction of properties of undiscovered elements. He given the property having the both atomic masses and oxide formulas. For that he was predicted. And noble gases plays separate group. You see, the noble gases, okay, is not make a noble gas separate group only made it. Okay, noble gas placed separated groups. Noble gas placed as separated groups. And also correction of atomic masses. You make correction of atomic masses. Like given that atomic masses formula also, that formula, while using the atomic mass formula, you can find this perfect atomic masses. He given that correction of atomic masses formula is you can write that atomic mass formula is equals to equivalent mass into valency. Okay, before he was given, if they are calculating wrongly, like equivalent mass of the beryllium, if we take, we got 13.5. You see, while before correcting the Mendelis, what they taking, that atomic mass is atomic mass equals equivalent mass into valency. Equivalent mass is that 4.5 into 3, we will get 9. Will get 9. No, it will get we'll get 13.5. we got 13.5, but it is not that atomic mass of beryllium. For that he given that perfect atomic masses, he taken that 4.5 into 2, we got that 9 is the atomic mass of beryllium. You see, atomic mass is 9.01, it is approximately 9, while the correction of atomic mass was done by Mendeleev. Okay, Mendeleev. Next we can talk about demerits, or you can tell that defects. Okay, demerits, or we can write that defects. You see, defects, what is the, why it failed? Okay, it not given the position of the hydrogen. First demerit is not given the position of hydrogen atom, because not metal. Okay, not a metal. If you take if it reacts with the first group elements, position of hydrogens, you see, position of hydrogens, you see, if you take the first group hydrogen, lithium, sodium, potassium, rubidium, cesium, if it reacts with the seventh group like fluorine, chlorine, okay, bromine, iodine, this all the halogens, we know that already, and I will tell that if you position of the hydrogen is not identify that, for that you can, if you see, if sodium reacts with hydrogen also, and also sodium reacts with halogens. Okay, similarly that the hydrogen reacts with chlorine atoms. And also the position of isotopes, first is position of hydrogen, second is position of isotopes. What is this? What is it is isotopes means having same atomic mass. I will write here, same atomic mass. What is isotope? I am telling, isotope is nothing but having a same atomic mass but differ in atomic, same atomic number and different atomic masses. You see, isotope is nothing but same atomic number but differing atomic masses. Like chlorine, you take chlorine, it acts that chlorine is atomic number, chlorine atomic number is 6. Sorry, carbon is 6, chlorine is 14. It must be get 34, or if it shows that chlorine atomic mass 35 and also 37, but perfectly if you talk that chlorine it acts must be shown that 35. Like that, the position of isotope is not identified by Mendeleev. Okay, third one is wrong order of atomic masses. You see, he made one mistake, that is wrong order of atomic masses. Why he made a wrong order? You see, the wrong order is nothing but, you see the cobalt atomic mass is 58.9. You see, cobalt atomic mass is 58.9. when come to nickel 58.7. you see, nickel must become here but cobalt must become it must be replaced, but he made a like this only the periodical table, Mendeleev. For that it is a wrong order of the atomic masses because nickel must become first, correct? No, but he made a cobalt. For that he made a one mistake. He made 3 demerits, that is position of hydrogens and position of isotopes and wrong order of the atomic masses. Okay, we are going to study about modern periodical table or a long form of periodical table. The last class we have discussed about Mendeleev for periodical table and merits and demerits, correct? No, now we are going to study about modern periodical table. It was introduced by Henry Moseley. Moseley and in 1913. You see, the Henry Moseley observed regulates in X-ray spectrum of the elements. You see, he was observed X-ray spectra of the elements. X-ray spectra of the elements is plotting a root mu against or versus by atomic number, that is Z. We can write, if you write a plot, you see it is mu is nothing but a frequency, it is atomic number. It gives straight line in Mendeleev periodical table. You see what do you give the Mendeleev's table? What is given? The elements arranged in the increasing order of the atomic masses. Mendeleev in periodical table, the elements are arranged in increasing order of the atomic masses, but we see that demerits also. But when come to Moseley, we talk mostly the elements, same we taken that elements arranged in the increasing order of, he taken atomic masses, but he taken atomic number. Okay, it is called as modern periodical table. For definition, we will write the definition. Okay, the definition is the properties of the element. I told in Mendeleev what is property. This is physical and chemical properties. Of the element. Elements are the periodic functions of their atomic number. You see, he taken that 18 vertical columns, he named that groups total 18. He taken that 7 horizontal rows, that is he taken that periods, it is 7. Okay, but in Mendeleev is taken that that in Mendeleev is taken that 18 vertical columns, he called as 8 vertical columns, he called that groups, but he taken that 18. He include that noble gases also, and Mendeleev is taken the 6 horizontal rows, but he taken 7 horizontal rows. Okay, it is called as period. Okay, next we are going to talk about periodical functions. Period number, or you can call as number of electrons shells. Okay, for example, you take hydrogen is first period, correct? No, hydrogen is first period. In hydrogen, the first period, we take Mendeleev only. The hydrogen is first periodical table, first period, no, then it has only one shell. If you take a sodium, Sodium is in third period, correct? No, sodium is third period. We'll write 1, 2, 3. 3 periods will be there in the sodium. Okay, do you understand this concept? Modern periodical is arranged. If we take in periods, okay, we'll write that periods, that is the first period, it's having shortest period, it's having only 2 elements, okay. The first period, hydrogen and helium. If we talk second period, it is shorter, not a shortest, it is shorter period, it's having 8 elements. If we talk third period, it's also shorter period, it's having 8 elements only. Already I told what is 8 elements. You see, the one period, it's having 1 shell, 3 periods having 3 shells, it's having 8. If we talk next fourth period, it's long period, having 18 elements. The fifth period having same long period, it is also having 18 elements. When come to 6 and 7, longest periods in both 6 and 7. When come to shortest, it is first period. When come to longest, it's having how many electrons will be there? It is 32 elements. It having 32 elements will be there. It's all the elements, we call that magic number, we call as magic number. We talk on that 7 periods also, correct? No, in 7 periods we taken that how many elements will be there, shorter and longer. Okay, now we are going to talk about blocks. That is, first we are going to talk about S block. S block, it is a least, S block, it is have the least electrons will enter to S orbitals. You see, S block is nothing but last electrons will entry to the S orbital. You see, the first group and second group, we take that it is a S block, first and second. Okay, you understand here? First and second, we take that group 1, group 2, correct? No, group 1 and group 2. You can see here group 1, group 2. Okay, in group 1, it is general electronic configuration is NS1. If you take for hydrogen, for example, hydrogen, it's having 1s1, correct? No, lithium, it is 1s1, 1s2, 2s1. Okay, it's last coming NS. It must be all the first group elements, it end, the electrons enter to S orbitals. You see, enters to S orbitals. Okay, next it is monovalent. We call it is monovalent ions, and it also called as the group 1, or this group, it is alkyl metals. When come to group 2, group 2 general electronic configuration ns2. You take beryllium, for example, beryllium ns2 2s2. You see, this is last ending, it is divalent ions. It also called as alkaline earth metals. Okay, we call the overall S block, you see, 1s1 ns2, overall the S block general electronic configuration, we called that general electron configuration of S block is ns, correct? No, ns 1 to 2. Then we will talk that characteristics. That characteristics is nothing but, first we will talk that it is a metal, correct? No, it is alkaline metals, it is alkaline earth metals, both are metals, these both are metals. Then it's having low melting point and boiling point, and it is highly reactive elements, group 1 or group 2, you take S elements. If it is highly reactive, it is highly electropositive, and it's have, if these elements, if we kept to a flame, it shows the color, for that they produce color to the flame, it's all the S block. It's last electrons will enter to the S orbitals. It S block having two blocks, that is group 1 and group 2. You see, group 1 and group 2. Okay, if you talk group 1 and group 2, it's a group 1 general electron configuration ns1, group 2 ns2, and then it's monovalent, it is divalent. Then it's alkaline metals, it is alkaline earth metals, it is general electronic configuration ns1 2. It is S block elements are metals, S block elements having low melting point and boiling point, and S block elements are highly reactive, highly electropositive, they produce color to the flame. Next we are going to talk about P block elements. Okay, P block elements, if you see the P block elements, now we are going to study about the P block. The P block is nothing but a last electrons will entry to P orbital. You see the P orbital in periodical table here, from boron to neon. You see helium also is added here. This, when come to talk of 5th, 6th, 7th, 8th, 9th, 10, all the elements. And if we talk the blocks, it will talk and 13, 14, 15, 16, 17, 18. The 18, from 13 to 18, blocks is nothing but a P block. This P block its general electronic configuration is ns2 np. See, it's, if you write for boron and neon 1, you see for boron this atomic number is 5, correct? No, if you write for boron 1s2 2s2 2p1, correct? No, for boron. If you write for neon it is atomic number is 10, 1s2, 2s2, 2p6. You see, for that we are writing that from boron to neon it's ns2, correct? No, and np1 to np6. This is the general electronic configuration of p block elements. If we talk about 13th group, we call that we'll talk that 13th group. 13th group is nothing but it starts from boron. No, for that we call as boron family. We call that boron family. Then if we talk 14th, it is carbon family. And next if we talk a 15th group, we'll call that is nitrogen family, or we can also call that necotogens. Why call necotogens? It is easily suffocation. For that we call nitrogen family is also called as necotogens. P is silent. Necotogens is also called as suffocation. Next 16th group we call as oxygen family, or cohalogens. Why we call as cohalogens? Because ore forming elements. Because all the 16th, oxygen, sulfur, selenium, tellurium, polonium, this all the elements easily it forms the ore forming elements. For that cohalogens is nothing but ore forming elements. Next we are going to talk about 17th group. 17th group is nothing but halogens. You can tell that is, so we can tell that fluorine family. We can also tell, but it is another name. It is halogens. Why we call as halogens? Because the halogens salt producers. You see, if these elements, 17th group elements, if it reacts with any element, it forms the salt. For that we call as salt producer. Okay. Next 18th group is noble gases, or we can also call that zero gases are inert gases, because all the group elements like neon, argon, krypton, xenon, radon, all the elements are completely filled of orbitals. You see, I written for example neon, you see is completely filled of p orbitals, correct? No, for that we call as noble gases. If you see s block plus p block, S is nothing but, already I told that S block elements is nothing but you see hydrogen, lithium, sodium, potassium, rubidium, cesium, fluoronium, beryllium, magnesium, calcium, strontium, barium, radium. These all the elements, if it reacts with these p block elements, represents the element expector. If you see, leaving this 18th group, if it reacts with all the 13 to 17 groups, if it reacts with S block, it gives metal or non-metal or metalloids. Okay, it represents representative elements. We call S block and P block. If both are combined, it forms representative elements, except if it join with except in p block 18th group elements. Okay, it forms a metal or non-metal or metalloid. Okay, and the p block elements most of all the bonded with a covalent bond or covalent compounds. The p block almost all the covalent compounds. Okay, next we have studied that p block, s block and p block. Now we are going to study about d block elements. Okay, see, we are going to talk about d block elements. Quite commonly d block will come from, you see, d blocks come from s block and p block medium in center of the periodical table, or intermediate between s and p block. Correct? No, intermediate between s and p block will be d block is there. For we called we tell that intermediate behavior between S and P block elements. The D block we also called as transition elements. Its general electronic configuration is n-1 d1 to 10, because it is 10 columns are there and ns2. The electrons, you see, d orbital, d block, the electrons is added in the d orbital of d electrons is added in the d orbital of penultimate subshell. What is penultimate subshell? I will explain. Electrons is added in the d orbital of the penultimate subshells. What is penultimate subshells? If you take, this is atom. Okay, this is a atom. The first, it is penultimate. Okay, the outermost electron shells filled by the d orbital, that is, first is a valency. If we talk, it is valency. Second orbital we talk in d subshells, penultimate. Third one is anti penultimate. Do you understand this? The electrons is added to a d orbital in penultimate subshell. I am talking in subshell of the d orbitals. It is having a 10 columns. You see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's having a 10 columns. In 10 columns, if you take a scandium, for example, I am taking a scandium. Its atomic number is 21. If you write the electronic configuration, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d. See, 3d, almost 10, 20, 1. It became 1. If you write similarly to the zinc. Zinc. For that one I have written that NS2 here, no, correct, and ND. It is zinc 30. It's similarly 1s2, 2s2, 2p6, 3s2, 3s2, 3p6, 4s2, 3d10. For that I am taken that D is equals to 1 minus 10. 1 to 10. 1 to 10. If you write for tellurium, same electronic configuration, last 3d 2. If you take vanadium, we get the 3d 3, 3d 4, 3d 5, 3d 6, 3d 7, 3d 8, 3d 9, 3d 10. Okay, like this. For that only we written the general electronic configuration. Okay, if you see, they formed colored compounds. They form, see the d orbitals. If you see, I am not talking about the p orbitals. P orbital does not show the color components. If you talk the s orbitals, they show the if they kept the elements into a flame, it shows the color. If but in d orbitals, they formed colored compounds. You see, if they ask which block elements which shows the colored compounds, is nothing but d block elements. Colored compounds, like example copper sulfate, it is blue. Okay, D block only shows the color components, but color which shows the elements when the S block elements if kept to a flame, but P elements does not shows any color. We will write this valency electrons. I told that valency. This valency is nothing but outermost electron shell I shown here. You don't talk this is SN1, 1s, 2s. I'm not talking because I'm taking the d orbital. In d orbital, it is the valency and penultimate and anti-penultimate. The valency electrons both valency shell and penultimate shell elements, they act as a catalyst. You see, penultimate and valency, they act as a catalyst. They act as a catalyst. Next, I am talking about last topic, that is last block, that is F block. F block elements, surely it will write that electrons is added in F orbital in anti penultimate shell. I think already I told that what is anti penultimate shell. Okay, this general electronic configuration is n-2 F1 to 14 n-1 D0 to 1 ns2. It's having two series. You see, it's having two series, that is lanthanide. You see 57. See, this is 57, 58, 59, 60. It will be joined here, but when come to modern periodical table, it kept below. Okay, why it kept below? I will explain. It divided the F block elements divided into two series of element, that is lanthanides and actinides. Lanthanides are rare earth metals. Similarly, both I'm telling that it's both are having a rare earth elements. Why it kept below? Because it is heavy metals, and it having I, melting point and boiling point. It's about the F block elements. Okay, next we are going to talk about the merits and demerits of modern periodical table. Okay, see, I explained this in S block. This is S block, these two row groups. If we talk 1 3 to 10, it's a D block. When 13 to 18, it is P block. Okay, sorry, 3 to 12 is D block. Then we talk, these F block elements are kept below the periodical table. Next we are going to talk about merits of D block, merits of a modern periodical table. You see, first we'll talk that merits. If you talk first merit, easy to remember the position of the elements, correct? No, easy to remember position of elements. Second point, table is clearly divided into SPDF. Table, correct? No, the table is clearly divided into SPDF. Table is clearly divided into SPDF blocks. Next, Mendeleev defect is rectified. Mendeleev is not joined that noble gases at all, and is not given the perfect periodical table. Is only Mendeleev arranged based on atomic masses, and he shown the defects in Mendeleev's. Mendeleev's defect is rectified. Noble gases are placed extremely right side, correct? No, noble gases, helium, neon, argon, krypton, xenon, radon. Noble gases are placed extreme right side. Next we are going to talk about demerits. He also not given the position of the hydrogen. Position of hydrogen is uncentered, uncertain or uncentered. Okay, and he have another demerit. It is F block is not included in main table. Next we are going to study about the nomenclature of elements with atomic number is greater than 100. Okay, nomenclatures. Okay, first of all, before going to nomenclature, we want to go to small history behind this. You see, the 92 elements are naturally elements. 92 elements are natural elements. And 24 are artificial elements. Okay, artificial elements are man-made elements. You see, nomenclature of elements with atomic number more greater than 100. You see, the one atomic number having the two names before 1987. After 1987, they given only one name. Before 1987, they given the different names. For example, you take atomic number 104 element, the one element having the two names, you see the Americans, they call that Rutherfordium. He given that element letter, that is RF, capital R, small f. Americans call atomic number 104, Americans call RF, Rutherfordium. Similarly, the Soviet, they called that Carochitium. They given that Ku, capital K, small u. Atomic number 104. And similarly the atomic number 107 also, they given the two names, that is Niels Bohrium, they called Ns, capital N S. Another name Bohrium, they called capital B, small h. These atomic numbers, you see, they are having the two names. When in 1987 the IUPAC system, what is this IUPAC? IUPAC is nothing but the overall the world, they must have the one element name. They given that one system, that IUPAC. What is this IUPAC means? IUPAC is nothing but International Union of Pure and Applied Chemistry. IUPAC is nothing but International Union of Pure and Applied Chemistry. The overall elements must be there. What the system tells, that overall the elements must be there in a Latin words. Okay, overall system. They not taken Americans or Soviet or any others. Like that, they make a one rule. You see, next they given another one. You see, if you talk atomic number 1 and numerical roots. Numerical root abbreviation. See, for if you take atomic number 0, then it must be nil in numerical root. In abbreviation, we will take small n. Similarly, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, for 0 it is numerical is nil, the abbreviation is small n. Similarly, 1, it's we talk un, small u, it is abbreviation. Similarly, atomic number 2, it is bi, we will take small b. Similarly, 3 atomic number, it is, we call that tri, we will take that small t. 4 we will take that quad, it is small q. 5 pent, we will take p. Similarly, for 6 we will take x, we will take small h. Abbreviations, 7, for 7 atomic number, it will take that sept, we will take small s as abbreviation. For 8 octa, we take o. For 9 we will take ena, we will write that small e. You see, the atomic number 0, 1, 2, 3, 4, 5 is, for 0 the numerical root is nil, the abbreviation is n. For 1 it is un, we will take as u. 2 bi b. 3 tri t. 4 quad q. 5 pent p. 6 x h. 7 sept s. 8 oct O, 9 N, we take small e. Let us we discuss some rules based on how to make an element name. Okay, naming, nomenclatures. Okay, some rules are there. Okay, let us discuss some rules. Rules. Let us assign the name to the element having atomic number more than 100. Okay, more than 100. Okay, first we'll take, for example, we'll take 101 atomic number. We will take 101 atomic number. See, the first rule, what will tell? First rule, write the numerical root in order of the digits present in the atomic number. See, write the numerical root in the order of digits present in the atomic number. You see, we are taking atomic number 101. For that, 101. Correct? No. For 1, the numerical root, the previous tabular column I told, no. For 1, we will write and. Correct? No. And write. And for 0, we take that nil. For 1, again, and. This is the first point. Write the numerical root in the order of the digital present in the atomic number. They are given atomic number 101. So 1 and 0, 1. It is numerical root. Second rule. Join the roots together. You see. Join the roots together. If you join, what will write? For if you join, you see, nil, correct? No, we are joining. Add a suffix. You see, third rule, add suffix. That is, suffix is ium in last. IUM in last. For example, you see, this is the root. Correct? No, we got that numerical root for 101. I am writing here UNILUN. Correct? Now we are joining together. Last, we want to add suffix. Suffix is IUM. This is called chemical name. Again, the fourth point, the symbol of the element is written in the first letter from the numerical root. See, all right. Symbol for the element is written from the first letter from the numerical root. You see, we written that the numerical root UN and nil. Correct? No, in this the first letter, you see, I am talking this first letter. First letter is U, it is N, here U. Correct? No? Yeah. this, the fourth point, the first letter must be a capital U N U. You see, U N U. Correct? No. Next, fifth point. Fifth point, name should be short and related to the atomic number. Fifth point, name should be short and related to atomic number. You see, this is very, very important. First, we are taking that numerical roots. Correct? No? Sorry. First, we are taking that numerical roots for what they given the atomic number. 1, 0, 1. I am taking the numerical root, that is 1 and 0 nil 1 and. Correct? No? Second rule, we want to join together. We are joined. Third, we are adding suffix to last of the root. We are added. Correct? No? Then fourth point, taking the first letter from the numerical root. You see, I am taking the first letter. I am taken that. Okay. Fifth, name should be short and related to the atom. Okay. Next, we go some while assigning the name of element, some elements some elements we are taking exceptions. We are talking for that elements. Okay. In that first we are going to talk that atomic number. Atomic number, name of the element, some have exceptions. That first we are going to talk 190. For 190, first rule, what we want to do? We want to add numerical roots. What we taken? 190. Correct? No. 190. For 1, we can write on 9 ENN 0 nil. Correct? No. Second point, join together. UNENNNIL. Correct? No. The third, add suffix. Suffix, we want to add suffix. No. UNENNILIUM. We added suffix. Next, the fourth, you see, fourth, for some of the elements we are taking that exceptions, like for if you see, for this type of, if n occurs before nil. You see what I'm taking, that n is occurred before nil, the second n of n must be removed. Means this n must be removed. Second, correct? No, n must be removed. Okay, if you remove, what happens? You see, UNENNILIUM. Correct? No. The fifth, taking the first letter from the numerical roots. UEN. Correct? No. UEN. Correct? No. Do you understand this? Only some elements like 190 and 102, 103. Okay, only 3 elements are exceptions from the tabular column. Second, we will go to second atomic number, that is 102 atomic number. Okay, atomic number. Similarly, the first rule for 1, what we'll get? UN. And for 0, nil, correct, no? Nil. For 2, it is by. We want to join together. Third, we want to add suffix. This is a suffix. The fourth, you see, the fourth will tell if by occurs before ium suffix, then I must be dropped. Okay, you see, I will write that if by occurs before suffix, that is ium, then I of by must be dropped or removed. Okay, you can write anything, removed or dropped. Okay, dropped. Then what will be the chemical name? Chemical name ACUN NIL B, only B. I we are removing, no? IUM. Then fifth, what is the fifth point? Fifth point, we want to take the first numerical element. That is, it must be capital UNB. UNB. Okay. Next, we are going to talk about the last. That is exceptions. That is third. It is atomic number 103. Only 3: 190, 102, 103. Okay. Number 103. Okay. If we talk the first one, for 1, it will be un. For 0, nil. For 3, try. Second, we want to join together, correct, no? Then third, we want to add suffix. Similarly, we got the 2 I's. What we want to do? We want to make fourth. That is, if try occurs before suffix or IUM, then I of try must be removed. I of try must be removed. Then you see, I of must be try IN remove ಮಾಡಬೇಕು. ಅವ್ರು remove ಮಾಡಿದೇನಾಗುತ್ತೆ? chemical name that is UNNILTR, correct, ಅಷ್ಟೇ ಈ IUM. Then fifth, we want to add first letter from the numerical root, that is capital U. While writing that last rule, first letter must be capital A, capital UNT. Okay, next class we are going to study about very important, that is how to find period, block.